All right, so let's have a look at this presentation. What are we talking about? I'm going to outline some vocabulary system patterns that I and Les, who's on the call here, and others of you have seen over the years in systems that we've implemented. Now, the vocabulary field is not a static field. It changes over time. The tools change, the organizations that are involved in this change. And we don't claim that what we're seeing here is representative of the whole world's vocabularies or even Australia's vocabularies. We're just talking about the vocabulary systems and so on and the experiences that we as a company that works in this field have seen over a little while. So we'll talk about those patterns. And it's to do with those patterns that we're doing this particular presentation today. We will overview in just a minute or two a couple of different tools and approaches. Then we'll talk about the new tool in particular, and we'll make a couple of comments about the future. Okay, so vocabulary system patterns. So one pattern that we see, so in terms of the way organizations consider and position vocabulary handling in their organization, the one way that we see organizations do this is a standalone project. You have a group in an organization whose job is to deal with vocabularies, and they might do other stuff. I don't think we've seen any organizations who've dedicated staff 100% to vocabularies, but the staff that are doing the vocabulary work are doing it outside of other bits of work. It's an initiative for its own purpose to usually standardize and harmonize and organize the terms of reference that are used by that organization. So Angela, who's on the call, has done a project like this at the Geological Survey of Western Australia. There was an initiative set up specifically to deal with vocabularies. Another example is the Northern Territory Geological Survey, who have a small project to just do vocabularies. That's a standalone project. There are other projects where we see vocabularies dealt with within a broader chunk of reference data, and the little image you see on the screen there is the Indigenous Data Network's reference data catalogue, which Les, who's on the call, works on. That reference data catalogue has got spatial data, it's got individual people, it's got a whole bunch of stuff, and vocabularies are part of that picture. So definitely not standalone, but yeah, embedded in a broader initiative. And then there's some yet other projects, again, which Les works on. The Biodiversity Data Repository, that's a very large national database. The vocabularies are there, they're important, they're critical, in fact, but they are background. They're not the main thing that the project team works on. They work on, and Mika has worked on this too, the main database is this colossal thing of observations of species around Australia, and the elements of the observations are described using vocabularies. So those are three different sort of prioritizations of vocabulary work. Vocabulary management systems. How are vocabularies actually managed by organizations that are doing specific vocabulary tasks? So one mechanism is an external database, and on the screen here you see a tool from which many of you may be familiar with, the NERC vocabulary server over in the UK. It's got a couple of hundred vocabularies in it. It's a dedicated vocabulary system, and yet the actual management of those vocabularies is in a database that's external from the vocabulary system. It's in a big Oracle database, in fact, in which they manage loads of stuff. So that's an external database way of managing vocabularies. Another way is a file-based version control system, and this is very common for us, and it's the main way we're working at the moment when we're dealing with systems that are just dealing with vocabularies. So in the Geological Survey of Western Australia's case, which I mentioned previously, there you have 50-odd vocabularies in a data document version control system, and that's how the vocabularies are managed. They're displayed in certain ways, there's different ways of interacting with them, but their actual point of truth is this version control system, and that works great for small to medium-sized vocabularies. Now everyone has a different impression of size, but just remind the audience that there are vocabularies out there in the millions. We do see systems which people call vocabularies that have got every gene under the sun in them, or viruses or something. So some people call those vocabularies, and those things are not amenable to being managed in files. But most of the classification vocabularies, types of pizza or whatever, those things definitely are manageable in files, and we see a lot of that going on. Another a way of managing vocabularies is not to manage them, to have someone else manage them for you. So Jun, who's in the call here, over a turn manages a set of vocabularies, and the Biodiversity Data Repository, it has lots of vocabularies actually, but one of those sets it doesn't manage, it just brings them in. It synchronizes in the turn vocabularies, and it doesn't claim to manage them. So Again, these are just three different sources of vocabulary management, and they are impactful on the tool design and the processes we've come up to deal with these things. Okay, so another aspect of vocabulary system patterns we see is the vocabulary access or publication pattern. And again, we're only talking about the systems that we work on. There are lots of tools out there that make vocabularies available in different ways, but the three modes of operation that we tend to see are human readable information, machine readable information, and these days, even though it's a part of machine readable information, we would say AI readability as well. So that logo that you see on the screen there, of course, is the tool that we develop and work on, the open source tool Prez. It presents vocabularies as web pages. That's one mode. And so that's a human readable side. You want to read about the vocabulary for, drilling method, you can go to the web page and you can see it all written out there. It's got a certain set of APIs as well. By the way, the flow of Prez operations is down the bottom there. So from a knowledge graph to profiles of the knowledge graph to web frameworks to APIs to JavaScript libraries and web pages. So human readable is down at the web page end. Machine readable is the next two sections, the JavaScript library and the APIs. So again, this is not the only product like this, but it's of a type. And the type here is that you have API access to vocabulary content. And there are any number of different APIs that people might use to access vocabularies. There are certainly some that are more common than others. There are general purpose ones like Sparkle endpoints that allow you to access any knowledge graph. And then there's specialized forms of vocabulary specific APIs which people use as well. We tend to use the Sparkle endpoints with certain linked data APIs as an additional specialized form of API. I'll just mention the last point there, C, AI readability. This has become very important because people want to use vocabularies in large language model AI situations. And so you can just point large language models and so on at vocabulary content, either as a web page or as a data file and tell it to read that. Another way you might do this, though, is to use a model context protocol API where a system such as a chatbot style AI can actually construct queries from entered text into a query that will match a certain underlying API as long as it has a model context protocol API to access it. So we do have systems in production now where you can say, what is the term that, what are all the types of fish, or whatever, and it will translate that into a query into an API that will query a set of vocabularies. Okay, so far in these three things, I've talked about, if we've got a vocab store in the middle there, I've talked about the management of the vocabs a little bit. I've talked about the vocabs coming out, and I've talked about the context of the vocabs in the organization overall, but I haven't talked about vocabs coming in. So that's the focus of where I'm getting to now, and that's where the new work has gone on. Okay, so vocab sources. How are vocabs made? And then I'll come to the tool and where it sits in that process. So again, there are more ways to make vocabularies than what I'm going to go through here, but these are the ones that we see. And I sat down in preparing this last night, and I just thought through all the projects that we've worked on with vocabs, which would be in the sort of 15 different project range, I would say, over the years. In my case, that's going back about 10 years. In Les's case, probably even longer. And how do people make vocabs? Well, some people make them from scratch. And what I mean by that is they don't have a source for the vocab. They are making the vocab right here, right now. And when they do make them from scratch, they have a range of tools that are available to them, which we're going to go through in a second. Another way of making vocabs, and an example of making vocabs from scratch, an organization that's done that. There are many organizations that do, but one organization is the Department of Resources in Queensland. It's got a new name now, but they've made a couple of hundred vocabs, some of which never had a pre-existing form. There was no vocab there. They made this vocab for a particular purpose. So they take intellectual property from their head and they turn it into a control list of some sort. Another mode is, and I just want to see if the next picture is more revealing. Non-semantic sources. So it's very common that vocabs are made from a pre-existing non-semantic vocabulary source, a lookup table in a database, an Excel spreadsheet, something like that. Where there is control, there is a vocab there. It's just not in the sort of modern semantic form that we typically like to see implemented. So Geoscience Australia has got a vocabulary system, and within that there are some vocabs that are made from scratch. There is a whole bunch which have been extracted from tables in their AuraProd main Oracle database system. They are vocabularies, no doubt, in that system, but they're not publicly available. They're not available as I guess, a semantic web style vocabulary. So they use tooling to extract those vocabs and make them available. The third mode I wanted to indicate is reusing others' vocabs. So the Northern Territory Geological Survey has got only a few vocabs that are under test at the moment. There's a few of them listed on the screen there, most of which are not vocabs that they've made up. What they've actually done is they've just pulled in vocabularies from Geoscience Australia, from the Geological Survey of Western Australia, and they will and do make up some of their own vocabs from different sources, textbooks and their own knowledge and whatever, but there's a proportion of their vocabs that are just coming in from the outside, and that's a good thing. They're not reinventing wheels, they're repurposing and reusing other vocabs. Okay, so where does this... Oh, sorry. First, a note about the tools that one might use to make vocabularies from scratch and elsewhere. So we in the company have spent time building up tools to help people create vocabs in different ways and different sources. And I'm just going to touch on those and then mention the big new tool, which is the thing that we're adding to the mix now. So making vocabs from scratch, you can make them in Excel. We have an Excel-based templated mechanism for doing this, VOC Excel, and that's just to structure the stuff that you put into the Excel in such a way that it lends to a good vocabulary. It's got best practices as we see them there regarding the kind of metadata that you would associate with the vocabulary, the structure that you would use, and so on. There's nothing stopping you typing out a vocabulary in a text file of any sort. Of course, we in our company are particularly interested in strongly defined semantic web vocabularies, so there's particular text files that you might use for those. If you're extracting the vocab from another system, like an Oracle database, you would have to have some kind of scripting language or software that would do that. There are many of those. We tend to use particular ones, which I'll show in a second, but there are many, many different ways of doing that. And then if you're reusing other people's vocabs, this might be a manual process. You might literally copy and paste the vocab from their system to yours, or you might use synchronization scripts, such as the BDR does, the Biodiversity Data Repository, where it automatically accesses Tern's vocabularies online. It checks them every now and then to see if they've changed, and it synchronizes them in. Okay, so I'm not going to go into any depth on these tools, but for vocabs made from scratch, I mentioned that you can use an Excel-based tool. On screen, you see a template there. You can fill it out. And there's software that will convert that into a vocab. So that's one of the tools. I'm not expecting you to take all of that text in, but what we see on the screen here is a structured text file which represents the content of a vocabulary. It is literally a text file. Yes, it has certain structures and so on, and it can be validated, but nevertheless, a person with a keyboard can type out one of these if they so desire, and that's a necessary way of working. We always want to make sure that the content that we deal with, you actually can ignore all the software and you can actually build a vocabulary just in a text file if that's what you want to do. And the last source, the way I'll mention here is using software. There are many ways of, many toolkits, as I mentioned. The one that we tend to use is this Python toolkit called RDF-lib. Why? It's free, it's open, it's comprehensive, it does lots of stuff. It's been around for 20 years, but it's also been updated and maintained. So if you want to write a script to extract some vocab content, you might use RDF-lib to do that. It can extract from databases, tables, you name it, it can read it. Okay, so what are we talking about today? We're talking about a tool called KMaker, which is a tool that we have developed that does a particular job with respect to vocabularies, but it's also a bit more general purpose. So if we look at the overall flow of information, what you see on the left are those spreadsheets, text files, and RDF-lib sources, feeding data, usually in our case, into a version control system, a file-based mechanism like, well, the protocol is Git, but the tool might be GitHub or Bitbucket or something like that. From there, we synchronize that content into an RDF database and then deliver that out through the Pres API in that human, machine, and AI readable form. So that's the situation we're in. Where does KMaker sit in this? So KMaker sits in there. It's another way of making vocabs. So it's got to feed into this version control system, but it's also an editor. So unlike those other forms where you might, in the Excel system, make a vocab and then feed into the system, you can do it, but it's difficult to then edit that vocab in situ using that Excel tool. You'd have to re-extract it back into Excel, make changes, and send it back in. You can do that, but it's not our preferred way of working. You can, of course, forever edit the text files of the vocab directly, and we have people that do that. I personally also do that. I know vocab content and structures pretty well, and so I get in and fiddle with content directly. So KMaker is an authoring and an editing tool. And crucially, you see what it's doing is it's talking to the version control system here. It's not talking to the RDF database. It's talking to the same system that many of our other tools talk to, and it's separate from that database, and that's by design. We can couple it directly to the database if we want. We can author a vocabulary straight into the database, but we tend to like to do things this way in this sort of two-step process because it allows us to maintain exactly the same governance mechanisms that we used for Excel-based authoring, text authoring with the KMaker tool. So there's no change from the overall governance situation, but now we have a new fun, shiny tool to use. So let's have a look at the tool. So here's a copy of the tool online, and this particular copy has been stylized to match, and it contains a copy of the content of Geoscience Australia's vocabs. But this is just a particular deployment. We've got other deployments for other purposes, which I'll show in a second as well. So what does this tool look like? Margie, who's on the call, is well aware of this tool. It's her team, and Rana, who I see on the call. It's their teams that we're working with for this particular deployment. The tool, KMaker, by the way, it's obviously a branded thing, but it's Knowledge Maker or something like that. It has it allows you to interact with knowledge graph material, one expected form of which is vocabularies, but there are other forms. So we can look at vocabularies here, and it'll give us a sort of a standardized printout of the vocabulary. So this vocabulary is a flat list. It's not particularly difficult to understand. It has vocabulary level metadata here, and we can edit that in a fairly straightforward manner. So let's just change the date created. We can add a value in there. You can see we could add a date in there easily enough. In fact, I will just add in, what is it? Is it the 2nd of June? 2nd, 6, 6. Obviously, this is not very real, but let's just do that anyway. Okay, so we've added the date in here. So this is a no technical knowledge system that we're looking at here. All of the bits of metadata and so on about the vocabulary are fairly well described. This little arrow for us to click on it will take you to a definition of what date created actually means. And what the system's doing is it's using the same version control mechanics that we've used in text-based systems and so on in a visual form. So that change that I've made is an unsaved change, and the change is date created. I've added the date created. Okay, great. And I can save that change. And what that change is going to do is under the hood, even I'm not I could be a non-technical person making this change, but under the hood, it's actually created a technical little so-called git diff. So as in it's made a differential file that has included the new information at the technical level, and it would then, on this button here, save that to GitHub. It will go and create the technical version control commands to actually lodge that change in the system. And if we looked into the version control repository that these vocabs are in, we would see that change now positive as a change. There's a workflow that's been implemented here, so that change can be proposed by a person with a certain access permission to the system, and then other people can either approve or deny or cancel or whatever they want to do. So it's exactly the same as if you were manually editing the vocab in the Git version control text files, with all of the appropriate workflows around that, but it's a tool which doesn't require any knowledge of Git. And I have to say, we've been many years in the making for a tool like this. Why haven't we made it before? Well, for many years when I was at CSIRO and Geoscience Australia and elsewhere, we didn't have the investment to make a tool like this. There are plenty of software tools that also make vocabularies. For instance, the ARDC has a pool party tool, there's Rockbench, there's many other tools. We always wanted a tool that would operate on the same version control principles as manual editing, but it's only now in the last little while we've been able to generate the capacity to make such a tool. We've made it for a couple of specific projects, including one with Geoscience Australia, but it is general purpose, and I'm now going to show you an altered purpose. So I think that's that slide. Okay, so the future. The future is, the way that tool works is it knows about the structure of the content that it's editing because that structure matches a pattern. And the pattern is a shapes definition file which defines, what are we looking at? We're looking at a vocabulary within a knowledge graph. Knowledge graphs can contain really anything, but if we describe the expected structure, we can make a tool to match that structure. So the expected structure here is a variant of the SCOS vocabulary model. The actual tools that interpret the structure and make the actual tooling, so the underlying development tools that make this user interface, some part of them are based on shackle user interfaces, which is a thing to associate patterns in knowledge graphs with certain kinds of tool structures. And that work is current and ongoing in the World Wide Web Consortium. And you'll see Edmund, who many of you know. Edmund is I'd say, the lead editor of that standard at the moment. So it's some knowledge of how to interpret the structures of knowledge graphs that allow us to make tools efficiently. And why that matters is it might be hidden when you look at vocabs. We all sort of understand, that a vocab would have a list of concepts and metadata and so on. But depending on the structures that we're dealing with, we might have very, very different requirements for a tool. So how do we keep the tools able to generate different interfaces for different structures of things? This is what I mean by going beyond vocabs, vocabs plus. Okay, so I'm going to show you another interface now that is built on the same mechanism as this one, the same underlying tool. It's branded differently for a different client, but it has a very, very different structure. I've put these grey boxes here to just hide some names, but otherwise, so you can ignore these grey boxes. I can't show you the name, but nevertheless, this is a tool that's being tested at the moment. It also does vocabularies, just like you saw for Geoscience Australia, but it also does data sets. Now, what are data sets? The data sets in this case are data sets that make specific sense to the customer. So you don't really need to know what the data sets are. They're data sets of some kind of product, and they're data sets of equipment breakdowns. I don't really need to know what these things are. Somebody knows somewhere, and they're able to make a model for those and feed those models into this KMaker tool, and the KMaker tool can then make a sensible user interface to deal with those special classes of things. It comes with vocabularies out of the box, but the purpose of this deployment that you're seeing parts of on the screen at the moment are that the client wants to make special kinds of knowledge in the database supported by vocabulary. So they want to make products, and the products have different classifications within them that are vocabulary based. So the next screen down is now we're looking inside the product list. So as opposed to a list of vocabularies, this is a list of products, and there are different ones in there, and they have different metadata. These are nothing like vocabularies. They use vocabularies, but they themselves are complex objects, not like vocabularies. If we look inside this particular denial of service business operation, again, these are not really things that I know what I'm talking about, but I don't need to. We can see that it has a product line, a coverage type, an IRI. It has different knowledge graph properties that this user interface supports. You can see there's a little edit button there. We have not had to make this by hand. This has mostly been auto-generated. I think it's entirely been auto-generated, actually, from our data definitions of the structure. Here you see an edit page, which mirrors the edit page of the vocabularies. When we click edit on this thing, it gives us the form options to sensibly interact with different parts here. So this is not live, so I can't click on it. But if I could, you would see that this parent risk thing, it's not just text, that is a drop-down list that is being sourced from a vocabulary. And what we said in the background is the parent risk categorization of this kind of object comes from that vocab over there, and the tool has made that drop-down list available. So in the past, when developing user interfaces like this, I would have to manually wire that up. I would have to say, there is a form, and the form has a slot for parent risk, and the values for that slot come from this vocabulary. So in the past, I would wire that all up using different technologies. We don't have to do that now. We just provide the data definition that says there's a slot for parent risk, and its values come from over there. We define that in data, we feed that into the system, crank the handle, and out comes the user interface. Now, we always polish the user interface a bit and add different colors and shuffle things around, but an awful lot of what you see is automatically customizable from the data definition. The order in which things appear on the page, the way they're grouped, the values, the legal values, the check values, all of those things are in the data definition. So vocabs come out of the box because we already know what that model is. But when someone comes to us and say, look, we want to do a vocab thing, but we want our vocabs to include these extra properties, what we do is we take our vocab model, we extend it to include those extra properties. In Geoscience Australia's case, they need to have an ECAT ID associated with every vocab. It must be of a certain structure. So we add in the definition for that, and then that becomes mandatory in the interface. If you had a vocab where you needed a cost code or a custodian from your organization associated with the vocab, whatever, we would just simply add that to the model, crank the handle, and a variant of the system would come out automatically that has those things there. This automatically generated mechanism is not foolproof. It does require testing and checking, but the time to generate customized interfaces is radically reduced from where we were a few years ago. Oh yes, just the last thing, again, back to the promise of this all being a semantic system. Even though this looks like a nice user interface that to some extent separates the person from the underlying representation of things, we always maintain direct access to the semantic content. So this form that you're seeing here that's being filled out is instantly generating the text over on the right. And because this is going to a version control system, if changes were made here and saved, and you didn't like them anymore, you could revert them using the normal Git mechanisms. You could also go into the repository and directly edit the text files of the vocabulary as well, and wind back or alter changes there. So we think that this tool then represents the best of both worlds. It's allowing us to have a easy to use, easy to generate user interface for knowledge graph content, in this case vocabularies and a few other bits and pieces, feeding into a system which has the fallbacks of the semantic content in kind of raw form, so that whatever goes wrong, if anything does go wrong in the user interfaces or elsewhere, experts can get in there and fix things. So I'm just going to go back to the picture I showed before, the positioning picture, this one, and just mention then, we've seen many years worth of different organizations making vocabularies, and we're pretty comfortable with the patterns that we've seen. We can support Excel-based generation, text, et cetera. We can support all those patterns, and now we can support a pattern which is a person who doesn't have great technical knowledge of the vocab structures. They might know their field very well, and what they want to do is get in there with a tool. It's a user interface tool, type things in, save them. They can also load a vocab that's been created by somebody else and edit it. And again, all the changes are saved in the same mechanisms as we had them generated previously. So that's a new addition. It's very exciting for us because we can deploy this to existing deployments. So where we have an organization that already has a version control system, an RDF database, and a presentation layer, and they've been doing things by hand or in Excel, we can come along and say, you're now able to use KMaker. We can just slap it over the top of their deployment. Of course, for new deployments, we now go with this as a product set. So for the Northern Territory Geological Survey, right out of the box, we said, look, we have a presentation tool here, Press, and we have version control management, and we have several different ways of entering content, including KMaker, that's available to them right from the word go. So we're expecting and hoping to keep deploying that tool for new organizations, but probably also to remediate, if you will, previous deployments where we actually go and make available KMaker on top of what they already had. I think that's my time. June, thank you very much for letting me speak. I'm happy to take any questions or no questions. It's entirely up to you.